All right, let's talk about one of the most critical strategies for anyone deploying software today, especially across multiple clouds: automated canary analysis. Think of this as the architect's guide to pushing new code without, holding your breath and hoping for the best. Let's dive in. So here's the game plan for today. We're going to start with the big problem, that multi-cloud dilemma. Then we'll introduce the hero of our story, canary analysis. After that, we'll get into how to automate it, see how it actually compares the data, and finally, how the system makes that all-important go or no-go call.
First up, the multi-cloud deployment dilemma. And really, this is all about the challenge of juggling just a ridiculous amount of complexity at a massive scale.
Okay, I want you to really picture this for a second. You're about to push a brand new version of your application, not just to one cloud, but to AWS, Azure, and GCP all at the same time. Now that question on the screen, what could possibly go wrong? Well, that's the stuff of nightmares for architects, right? A tiny little misconfiguration on one platform, a super subtle performance issue on another, the potential for a total disaster is huge.
And this is your world. As a senior architect dealing with multiple clouds, you are the last line of defense. Your job is to keep things moving fast, to innovate. But the number one rule is you cannot break production. You have to stop that catastrophic failure before it ever gets close to most of your users. So how on earth do you do that?
Well, that brings us right to Section 2. How do you prevent disaster? You use a modern safety net, and it's called canary analysis.
At its heart, canary analysis is a really simple but incredibly powerful idea. You take your new code, that's the canary, and you release it to just a tiny, tiny fraction of your live traffic. We're talking maybe 1%, 5% at most. This small group becomes your real-world testbed. It lets you see exactly how the new code is behaving with real users before you ever risk a full-scale deployment.
And this is the perfect way to think about it. The name is literally from the old practice of miners who would carry canaries down into the coal mines. If there are any dangerous gases, the bird would get sick first, and that was the early warning for the miners to get out. Your new code is that canary. It goes in first, and if it starts to struggle, you know you need to pull it back before it hurts your entire user base.
The whole process really boils down to 4 key steps. First, you deploy the new canary code right there alongside your stable production version. Second, you carefully peel off a small slice of user traffic and send it to the canary. Third, and this is the most important part, you analyze its performance, comparing it directly to your baseline. And finally, you get to the big decision. Does it get promoted to everyone, or do you hit the rollback button? Okay, Section 3, automating the watchful eye. Because let's be real, nobody can just sit there staring at dashboards all day. That doesn't scale. Here's how we automate this whole thing across all your cloud environments.
The real power here comes from having a consistent playbook. It doesn't matter if your canary is running on AWS, your automated system is doing the same thing. It's continuously comparing the vital signs from the new canary deployment
Directly against that stable, boring, beautiful baseline version. And then you hop over to Azure, and what happens? The exact same principle applies. This creates one unified, reliable safety net
that just scales with your infrastructure, no matter which cloud you're on, even GCP. It's one automated standard for quality everywhere.
And this brings us to the real heart of the matter in Section 4, the canary versus the baseline. This is the data-driven showdown, where the numbers, and only the numbers, do the talking.
Okay, so let's look at what the system is actually seeing. On the left, you've got your baseline, version 1.0, just chugging along perfectly. And on the right, our new canary, version 1.1. You can see there's a tiny little bump in CPU, a fractional increase in the error rate, and a 2 millisecond increase in latency? Now, these numbers aren't a 5-alarm fire, but they are different. So, this is the million-dollar question, right? Looking at these metrics, would you, as the architect, give the green light? Is it safe enough to send out to 100% of your users? The answer? Well, it all depends on the rules you set beforehand.
And that leads us perfectly into our final section, the automated go/no-go. This is where the system, with no human emotion involved, delivers the final verdict.
So, what's the call? It all boils down to a number, a single threshold that you define way ahead of time. Let's say your organization has an incredibly high standard for quality, and you decide that any increase in the error rate over 0.01% is just unacceptable. That one number is your line in the sand. In our example, the error rate went up by exactly 0.01%. And since that hits our predefined threshold, boom, the system triggers an automatic rollback. There's no meeting, no debate, no, well, maybe it's okay. The canary is just instantly pulled from production. Now, if that error rate had stayed flat, the system would have seen it was safely within the rules and automatically promoted the release to everyone. That is data-driven safety in action.
So why does all this matter so much? Well, because it prevents those massive headline-making outages. It protects your users from ever seeing buggy code. It actually lets your development teams move faster because now they have this incredible safety net. And maybe most importantly, it builds this deep, real confidence in your ability to operate safely in a really complex, multi-cloud world.
And that leaves us with one last thing to think about. Once your deployment process is this smart and this automated, it frees you up to focus on the bigger picture. So I'll leave you with this question. In this whole pipeline, what is the one decision that shouldn't be automated? What's the strategic choice that still needs the wisdom of a human architect? Something to chew on.